Hi everyone. So in this video, I'm going to show you how to call Go code from C++. In a previous post, I actually wrote an article uh, on how to call C code from Go. So I recommend you go through this blog post, and there is also a video for that as well. And so in this video, I'm going to discuss about doing the reverse, basically calling Go from C++. Why I chose C++ is because I can show some other useful techniques that you can employ in calling C++ code back from Go as well. And otherwise, the concept is similar. Basically, you can do the call to Go from C as well. So let's get started. So this blog post is available. I will post the link to this blog post in the description section below. And you know this is a very important functionality which kind of opens up a lot of possibilities when it comes to developing applications. If your application is being written in C++ and you may want you may have come across a cool library in Go and you want to make use of some of the functionalities available in that Go library, you can utilize this mechanism to interact or interop between these two different programming languages. And the reason that you might want to do that is because you don't find a corresponding library or the functionality that you have in Go in C++, and you may want to save some time there and utilize Go. However, this functionality also has some drawbacks, which we'll discuss, basically in terms of performance and all that. You won't be getting that native performance that you see in C++ when it comes to using this functionality. Well, so what makes this possible is this module called cgo in Go. So in if you just look in the documentation, also you'll find the details there. And what cgo makes it is like it just bridges the two worlds, and you can build your Go library as a C shared object or C library or dynamic link library uh, in your respective platforms. And then in C++ or C, how you access that functionality that Go has provided is irrelevant. It just looks at that shared object as another object, and it doesn't know that it's actually interacting with a Go functionality and so forth. On the reverse side, Go when you call C code from Go, um, Go is well aware of the C because of this C Go uh, language or the module, I would say, right? And anyhow, so C++ to Go, the main function is you have a Go code and then you have to build that Go code as a shared library. So let's get started, and when you see an example, you will better understand. So I have this Go code and I want this functionality. There's a function that I'm having as factorial. Obviously, this is a very trivial example. It's not that you cannot implement factorial in C++. So just to keep the sample very short and easy to understand, I have used this. So basically, this particular function takes an integer. This integer is a Go integer. It's the type is relevant to Go, and it's a function, and it returns something called cint, not a Go int. So that's because I have imported this cgo module, and that's what makes this integer available. So basically this says it's a C specific integer, not a Go specific integer. Well, because I'm going to return that integer later on to my C++ code, so it needs to understand that data type, and that's why it's returned as cint. So, and once you get this integer, I'm calling another factorial function to calculate, because calling a factorial function is basically a recursive function call. And if the past n value is greater than 0, we do another calculation. We basically multiply that number by factorial of 1 less that number. So that's how it becomes a recursive function, and then we return that result. Otherwise, we return 1. So this. I'm not going to explain that algorithm further, and that calculates the factorial. And once the factorial is returned, so this will be a U in 64, which is of Go type. So converting that Go type to a C integer type is quite easy. So you just call C int and your whatever your value, and you return it. And that's it specifically. And when it comes to compiling your Go code as a shared object, you need to have this main function, empty main function, and also you need to have this export functionality as a comment indicating that this particular function needs to be exported in the in the C code or the C library. Right. So let's get let's open up the integrated terminal here, and then I'm gonna let's see if I think I already have built some of the uh, functionality. So let's anyway, it doesn't matter. So let's build it again here. So I'm gonna copy this. So see how things are built here. Go build mode is C shared, and my output object is lib factorial go.dylib. I'm using dylib because I'm in a Mac machine, but if you're running this in a Ubuntu or Fedora, whatever, you will be using .so, and then you give your Go file. So once you do that thing, Go will build my dylib as well as it will output a a header file. So now if I just go do this, you will see that this has just been generated, right? It has just been generated, and fine. So now if I just try to peek into libfactorial Go, it is an auto-generated code, and you can just look into that. But the important thing is you will see this factorial function, and with a go int. So this go int it does work in C++ because it's a primitive type, and there's no much fuss about interacting with those primitive types, right? So now this factorial is available in this lib factorial go.h. I need to import that in my C++ code. So once I have it in the C++ code, I can view that factorial function and I can call it. And now to build that it's very simple. So it's just calling a function there and writing the C++ code, which is here. And then I'm going to build it. I'm going to build it using G++. You see, I have built it some time ago, but now I'm going to build it again. And you'll see the time changing to August 19th. So let me just do this again. So now what I'm saying here is I'm using G++ GCC specific C++ compiler, and I'm outputting a binary called mycpp test, and my source file is mycpp test.cpp, and I'm giving the library location to look into as my current directory where I find the lib factorial go, which is been linked using the -l flag. Okay, so when I do this thing, it should build my C++ code, and obviously now you see this is newly generated, and let's run it and see. So factorial of 5, you know the value, and when I run this, you will see 120. And nowhere in my C++ code I have implemented a factorial function, and it's obviously getting written from my Go code. So that's a very simple way of calling Go from C++. But there are complex scenarios than this, right? So it's not as simple as this in the real world. So let's look at some class specific scenarios, and in a real world C++ you will see classes, right? You will see a class like this. For example, I have a class called message, which has a constructor which has two methods, set message and get message, and it has a member variable called msg for message. So that example is also explained here. And now my objective here is, uh, in my main function, I want to call a go function where I want it to do some calculation, and I want to pass some values from C++ as well. Maybe that's possible, right? So in the previous example, we passed an integer. Likewise, you can pass a string. Usually, a string is a better option because it will, uh, it's a character array end of the day, right? So you can pass that quite easily, or a primitive type you can pass it as well. So I want to pass, and I want to make go calculate something, or do that, and set this message to in C++, and that is what I'm trying to do here. So basically, go calling back to my C++ classes member function. How do we do that? And I'm calling from C++ the Go code, and Go doing a certain calculation, and then maybe coming up with a new message. And then it wants to set that message from whatever that you calculated in Go in the C++. So you may be thinking, okay, maybe it's better to return that string. Rather than returning, calling functions back into C++ is quite easy. And that's exactly what I'm trying to do and showcase here, and together with some smart moves. Okay, so let's first have a look at the Go code. So, there's a little bit of a chicken and egg problem here, because Go code needs to understand the C++ code, and C++ code needs to understand the Go code. So maybe I'll first try to explain here. So I have this unique pointer created, for my message class, which is very easy. And I'm setting the message to hello from C++. And obviously I'm printing it in C++. The message, obviously you should see hello from C++ here. And then I'm calling something called go execute. That means I need to have a go execute method in my Go code. Exported method needs to be there, as we did for previously the factorial method. I need to have this go execute method, and it does look like there are three parameters, and one parameter is this message dot get. So this message dot get will get the raw pointer of the message unique pointer, and I'm converting that to a long long. Why I'm doing that, why I'm casting using reinterpret cast. Reinterpret cast is needed because I'm casting a pointer to a long long, completely a different type. So this is something a little dangerous in C++, but at the same time very powerful, which gives us the opportunity to accomplish functionalities like what I'm trying to do now, right? And that's because long long is a primitive type. Both the C++ and Go world understands that, and Go world will not understand C++ classes nor the pointer types, all that, right? And it's better to convert it to a primitive type, and that's exactly what I'm doing. So basically, when you cannot pass this message, and if you just try to pass this message, Go will not understand that. So that's exactly why it's been casted back to long long. And I'm also passing two callback functions. It's look like a function object of that I'm passing, and that is from this message go wrapper. So that's because, again, Go doesn't understand C++, so it doesn't understand any class concepts or anything, but it does understand some C level concepts like functions, function pointers, all that. It knows the pointer, and once it knows the pointer, it basically can call it. And that's why we have this wrapper function for our message function, with two static functions within the class, of course. So when you have a static function within a class, it will have a kind of a static scope, and that's like not bound to that particular class's instance, so it's available as a generic function even without an instance. So we have this get message, and it does have this handle long long, familiar long long. So that's because I'm expecting from Go to pass back my unique pointers handle. which we converted to long long here, and I am reinterpret cast that back to my message pointer. So because I know this handle now stands for, or it represents my message pointer, the raw pointer, and that's why it's not a unique pointer here, it's a raw pointer. And once we have this raw pointer, I can utilize this particular class's function. So that's how I reinterpret cast that back to a real class object pointer, right? So that's basically what we are doing here, and then interacting is quite easy. Now you get what I'm trying to do here. So we know that these two functions should exist. So let's go and look into Go code and come back. So I'm going to expand this a little bit so that you see the code well. So there is a little bit of a comment section here. You will see why and what is that important. Why is that important? And I couldn't mention previously in C Go you need to have your package as always main. You cannot have a different package name and it will fail. And always have it as main. And so apart from this C import, I also have other imports. The format import is very familiar to any Go developers, but this unsafe is might not be familiar, but it's important for this particular tutorial. And once we have that, what we can do here is uh, I am exporting this Go execute. Obviously, we need to have that because I'm utilizing that in my C++ code. So now Go execute takes a message handle, and obviously I'm using C's long long. Obviously, I'm passing a long long uh, type from C++, so I need to have the C long long. And now my callback get message and set message, and you see the C dot get message body callback and C dot set message body callback. How did this C get to know about it? This is not, these two are not standard types like long long. So how we tell that to go is by using this comment section. Basically, whatever you write within this comment section, just before this import C is a C code, and which Go will understand using that C dot notation, right? So this import C, it remember there shouldn't be a blank line or space in between these two, right? So see, this is line number 19. The comment should end at line number 18. It cannot have a space like this, right? So you should not have that space, and that's a very important thing. And I define my get message callback as, it's a type definition which returns a const char pointer and takes a long long. That's it. And I have another type definition, and these two are two static functions basically, so which Go will now be able to call. And within that function parameter, you see I'm passing this particular callback and a context handle long long. And then with that, so now this will be the same type as the C++. When I use this callback type to call, which will be a which would have been sent by the C++ and be captured here in this section, and when you pass it back to here, it is actually the C++ function pointer. And when you call it, it will actually call the C++ function, those static functions that you saw. So that's exactly what is happening here. So let's now look into what's happening inside this function, which is important. And also remember this function main that I mentioned previously. And right, so now this callback is sent by the C++ code. We know that now function pointer is available. So I'm now calling C get message body helper, which is this one, and I'm passing my get message body callback, which is of this type, which we defined here as available. And I'm passing that, and this message handle is the pointers long long. As you can remember, we reinterpreted cast back the unique pointers, the raw pointer into the long long, right? So then basically when you do this, it will call the message body, and it returns a const char pointer, and that's exactly what is returned here. So this is the message body in C. You see the message body in C there. And you see also, so this is a C thing. So when I want to print this message, so at this point, this is hello from C++, because that's what we set initially. And I need to convert this to Go string. To do that, that function is available in that C Go module. And with this method called Go string, and converting a C string to a Go string, this is how you do. So this is, we know it's a C string now because this method is a C method or C++ method, and it returns back to me the const char pointer, and I have to cast it as well here. So, and then I use this, and what comes here is basically a Go string. And this is what I'm printing here, message body in Go, and this should print as hello from C++. And then I'm modifying this hello body message body in Go with this addition. Now this modification we are doing in Go, and now this is again a Go string, and I need to convert this to C string to call to my set message, because set message is expecting a const char pointer, right? So which is this. Now remember, converting a Go string to a C string means underneath cgo is dynamically allocating memory, and it will not know when you want and don't want that dynamically allocated memory. So that responsibility is in the developer side, and this is where we are using this free function from the C. It's just like the malloc and free in C. It's just calls the free function, and to that we need to pass in our uh, the C pointer object, and it's a pointer object, and this is where this unsafe module comes in. Unsafe pointer, we had to specifically mark that as unsafe, otherwise it wouldn't know, and I'm deferring it because I want this to be called once we exit out of this particular go execute, where I know that it's been passed on to my C++ code before that. So once we have this message in Go, set message callback that we passed is passed back to the message body helper, which is here, and it will come here, which I'm calling here using the context handle and my message body, which is a const char pointer. So that const char pointer is what we just created here, and once we have this thing, it should go back to C++ and call this function, which eventually sets the message here, and that's after go execute in C++. After the go call, if I get message it, I should see hello from C++ with what's modified in my go. So let's basically have a look at this, build it and see it in action. So to go back to my code here, for this let me go into this section here. And here again I have some build stuff, so let's build it again. So first I want to, just like we did it before, the explanations that I just did is also there in the blog post, so if you want to go back and look into it, you can do so. So let's have a look. Now these were previously built some time ago, so this code I just modified, so let's build it again. And go build mode is C, output go interop code dot dylib, and my interop go code, which is this one. And when I build it, it should output the dylib and the header file. Okay, it's done, and so let's go back and see. So these two are just now generated, and of course now this interop code is imported here in the C++ code as well, just like we did it before. And now we need to compile this. So always you will compile the Go stuff first because it will have the header file, and then you come to the C++. And let's go here and get the C++ build thing. Fine. So to do this, I'm using this command. So I'm using my output is my cpp class test, which is this one, and I'm giving my class file or the source file. And again, as previously, the library location is the current path, and I give the library as go interop code, which is this one. And I also use this std parameter to G++, saying that this is a C++20. Whatever you put like C++11, 14, 17 also should work here. So that's because I'm using this unique pointer, smart pointer functionality, which only became available post C++11. So I'm using this, and it's good to use the latest versions. Um, so this should now build it. And now if I see this, it's again built now. So now let's call our binary, this one. And when we call it, obviously in C++, hello from C++ is called this one. And this gets printed from Go, message body in Go. If you see here, the message body in Go, and this came from C++. And now again back to C++. In C++, after the Go call, hello from C++, and with the modified message, and this is from Go, and which we are printing in C++. So this is the simple intro operation that you can do with Go, and this is a very powerful mechanism, and which makes the two world meet, and you can make use of a lot of functionalities, and you know utilize libraries back and forth between the two worlds. And I hope you enjoyed this video, and I will see you again with a similar video again in future. And happy coding and happy interoperating between the two worlds. Take care. Bye.